Hi everybody, so this is the rest of the review we didn't get to finish yesterday. So this is just getting us ready to start Calc 1 and going over a few algebra and trig things that will be important. All right, so here's where we left off is composition of functions. So if you don't remember, let's just say composite, which we write with this little open circle, f composite g of x means we're doing f of g of x. So you're starting on the inside with g of x. You'll get something, and whatever you get, you plug into f. So this one says f of g of 2. So I'm going to set it up of f of g of 2. So I look at what g says. G says whatever you get, you're going to do 5 minus that. So let's leave the f. I haven't used it, and I'm going to do 5 minus 2. So this says I have f of 3. So 5 minus 2 is 3. So now I know what to do. I take the 3, and I plug it into f. So f says I have 2 times 3 squared plus 3. Grab your calculator, do it in your head, whatever. 3 squared is 9, 9 times 2 is 18, 18 plus 3 is 21. So you're just plugging it in and going along. I'm going to do it again. I switched the order. I did G composition F. This will show you that order is important with composition. So this time I'm starting with F and I'm plugging in 2. So my f, remember, was 2 times 2 squared plus 3. Again, 2 squared 4, 4 times 2 is 8, 8 plus 3 is 11. G says I do 5 minus whatever I'm given. So I was given 11. So 5 minus 11 is negative 6. Look at the difference in the answers. I did f composite g of 2, I got 21. I did G composite f of 2, I got 2. This just shows that it matters what order you do something. All right, we're going to do more composition. We have composition a couple times, so that was doing it like algebraically. This is a table. Later we have a graph. Same thing is happening here. We have to look at where am I starting. So I'm starting with g of 2. So in this chart, I'm looking for here's 2, and I look at what does g say. So g of 2 is 0. So I'm starting with g of 2 is 0, so now I have f of 0. Go back to the chart. If I look at f of 0, it says 2. So this kind of bounces around. So I started at 2, it sent me to 0, so I go to 0, f of 0 is 2, so I came back to kind of where I started. Let's try that again. I have g of f of 4, so I'm starting with 4. Here's 4. I apply f, it gives me 6. So now I have g of 6. When I look at 6 and I look at g, it says 8. So again, that bouncing around. 4 sent me to 6, 6 sends me to 8. F of 0 says you can composite a function with itself. So I start at 0, f of 0 is 2. Then I look at f of 2, so at 2 it sends me to 4. So here's my answer. All right, so I did a quick change on that. I didn't have enough information to do g of 0. So let's do g of 3. So g of 3. So I have g of 3. So that sends me to 2. So now I have g of 2. So I went from g of 3 is 2, and then g of 2 is 0. What happened earlier, I did have written in here we were going to do g of 0, but g of 0 is negative 4, and that wasn't defined. So I kind of got stuck and said, let's make a quick change on that one. All right, more composition. This time we're going to do it graphically. Same kind of ideas though. We're starting inside out. So this f of g of 2. So notice this big curve. This big curve is my f. The line is my g. So that's what we want to use. So we're going to start at g of 2. So at 2, I'm looking at this line and I see this point right here at 0. So g of 2 is 0. So now go over to f and it says f of 0 is also 0. Okay, so I started at g of 2, I got 0. I take that 0 as the y value. It becomes the x for my f function, and I got 0 again. The next one I have is g of f of 8. So I look over at f of 8. It's right here. F of 8 gives me 0. So now I go look at g. When I look at 0, I get 2. So I started with 8. Y value is 0. That y becomes the x, becomes the input, and I get 2 as my output. The next one says f of 2. So I'm starting with 2, I'm going to f, and it says -3. So I'm going to go over to -3, and I look at the y, and it says -2. It looks like I cut off my graph. I can't see how g of 4 went to -6, and I cut off before it got to -6. So let's pick something else. Let's do like g of 3. That'll work. So if I go g of 3, it gives me -1. So I'm going to go -1. It gives me +3. So it happened to send me back to where I started, which is fine. But I want you to think the idea of you put in an x, you get out a y. That y becomes the x for the next function, and you just repeat your process. Right. This is called a piecewise function. It has pieces. What you have to do is start with where is my number. So the first thing I see is for this function f of x, which is 4x where x is greater than 2, and x minus 3 when x is less than or equal to 2, I look at my input of 3. So 3 is greater than 2. So because 3 is greater than 2, I'm going to multiply it by 4. So I'm going to have 4 times 3 is 12. My next number, -5, is less than or equal to 2. So with the -5, I'm going to do -5 minus 3, which is -8. So the number that you're given in the parentheses tells you if you're using the first or the second line. Then 2. 2 is where it's less than or equal to, so I want to do 2 minus 3, which gives me -1. So with pieces, it matters which piece you pick. You get one input, one output, so you can't put in both. You have to use the one that is satisfied by the x value. Right. A couple questions on domain. Remember, there are basically two problems with domain. You can't divide by 0, and you can't take the square root of a negative number. So in this rational function, 5 over x minus 6, I just would want to say x can't be 6. G of x, which says 2 or x squared plus 4, well, that's never going to be 0. When you square a number, it's positive or 0, and then you add 4, so now it's greater than or equal to 4. So in the second one, this is all reals. So I don't want you to think just because it's irrational that it's going to have restrictions. It could be that everything works. And then h of x, where it says square root of x minus 7, we need x minus 7 to be greater than or equal to 0. I can't take the square root of a negative number. So this x minus 7, I change that to x is greater than or equal to 7. I just move the 7 over. If you wanted to write an interval notation, this would look like 7 to infinity. X not equal to 6 would look like negative infinity to 6. Union 6 to infinity. You should be able to tell from the question how you're supposed to put in the answer. I'm not trying to ever confuse you, so you should be able to tell by the context. If it doesn't say, then either one should be fine. Here's a little review about exponents. Just what do we do with these ones that are unusual? So remember, when I have x in the denominator, that means I have a negative exponent. So 1 over x cubed is x to the -3. Radicals become fractions in the exponent. So the square root of x, it's understood that there's a 2 there. So this is x to the 1/2 power. Same kind of thing with the 5th root of x cubed. It is going to have a fraction, and that 5 is going to go on the bottom, but this 3 as the exponent goes on top. It is terribly important that you know how to do rules of exponents to take calculus. So if this is looking unfamiliar, I would definitely say go back and review some properties of exponents, because we will use them all semester. Super, super important for calculus. All right, let's do a little solving. All right, let's do a little bit of solving. So this says x squared is 36. I want you thinking the power tells me how many solutions I'm supposed to find. So power 2 says 2 solutions. We can use the square root. We can use the square root. We can just take the square root of both sides. So the square root of x squared is x, square root of 36 is plus or minus 6. Remember, 2 solutions because it's power 2. With x squared equals 5x plus 66, I really think I should try to factor. So I need to bring everything over to the left side and set this equal to 0. Luckily, this is not going to be a bad one. If I look at 66, I think it's 11 times 6. The 5 is negative, so I think let's make the bigger term negative, let's make the smaller term positive. Here's x, here's x. So 6 times 11, 66, negative 11 plus 6, negative 5. This says x is negative 6, this says x is positive 11. Two solutions, power 2. One more solving. This one instead involves trigonometry. So we have 2 cosine of theta equals 1, and we're supposed to solve over the interval of 0 to 2 pi. So what I would first do is I would take this 2 cosine of theta equal 1, and I would divide by 2. So now I have cosine of theta is equal to 1/2. So what am I thinking about? I want to know, well, what values of theta give me 1/2? So it kind of like you're thinking cosine inverse, right? Cosine inverse of 1/2 equals theta. So hopefully you're thinking, oh, well, I know cosine of theta is equal to half at pi over 3. And that's in the first quadrant, but where else is cosine positive? So remember, cosine is positive in the first and the fourth. Remember, cosine is kind of like looking at the x. So this x is positive, here x is negative, here x is negative, and again, it's positive over here. So I should also have, so this is pi over 3. And if you want to say this is negative pi over 3, that's fine, because then you could do 2 pi minus pi over 3. Like if that makes you happy to do it that way, that works for me too. And this would be 5 pi over 3. It's kind of like how you do math and what you remember about the unit circle as to how you're going to approach this. So here's your 2 solutions, pi over 3 and 5 pi over 3. All right, so that's just a quick review. It's a few things that we're going to talk about this semester. Of course, as we go, I will do more review. It'll kind of come in as we do the lesson, but I did want us to have some first place to start off. You have a review assignment to do as well, so I hope this was helpful.